Hello, calculus students and seekers of truth. Welcome to the video on parametric applications in two dimensions. In other words, two-dimensional motion. Okay, and when we work with two dimensions, we are going to have to work with vectors. So let's quickly and briefly review what a vector is. Okay? Now, a vector is a quantity with magnitude and direction. That's the strict definition for it. But in more layman terms, in intuition of vectors, it's that a vector just simply does not indicate where something is. Rather, it explains or it gives information about how something is changing. So that is the fundamental idea behind a vector, is that it's not really describing a location, it's describing a change. Okay? Now that change could be change in position, that could be change in force, it could be change in velocity, okay, all these other terms. Okay. So let's just look at a very brief example here that says, interpret the meaning of this vector. Remember the notation for a vector is the name of it, in this case u, with a half arrow above it. The first number is the horizontal component, and the second number is the vertical component. So this is like saying that I have some point here, okay, and it could be, this point could be anywhere, but let's, for the sake of an example, have a point being here. May or may not be the origin. This vector basically says its change is going to be 3 to the right and 5 down. Okay. Whatever this object is, this arrow here that I'm drawing describes the way that it's going to change. Okay? So this right here is really vector u. 3 to the right and 5 down. Okay, so this is the change and vertically changes by increasing horizontally by 5 and vertically by horizontally by 3 and vertically by -5. Okay? Now, the magnitude of a vector is written this way: is the absolute length of the arrow that represents it, which in this case we can calculate would be because this length here is 3 and this length here is -5, so we could calculate this as being the square root of 3 squared plus quantity -5 squared, which comes out to the square root of 34, which is about 5.83. Alright? So whatever this particle or this point is, this vector describes, and it says that it's going to change 3 horizontally, -5 vertically, and in total, its magnitude, the total change that happens to it, is root 34. And this is currently pretty abstract, but we'll develop this concept further by looking at some more specific and concrete example. Okay. Now, with when we learn about calculus, you're also going to learn a little bit of physics, because calculus and physics are intricately connected. And also it's a very common way to teach calculus by learning some physics. And we know from physics that a velocity is the change in position with respect to time of a particle. And the velocity here is a vector. It has magnitude and direction. So, for example, if this was the velocity of a particle, then it would mean that it increases in position at a rate of 3 horizontally and decreases in position at a rate of 5 downwards. Okay? So it's a vector with directions. But its speed is the magnitude of velocity. In physics, speed is the magnitude of velocity, and speed is always positive. And this is not really some equation or concepts here that I'm deriving. This is just really a definition. In physics, when we say the velocity, it means that the velocity is a vector with direction. It's moving in a certain way, 3 to some direction, 5 in some other direction. And so using this example, the vector would be 3, -5 for the velocity, and the speed would be √34. In other words, this is how fast it's moving. This vector describes not just how fast it's moving, but how fast it's moving in each direction. So hopefully that was a gentle review of some of the things you may have learned in pre-calculus or some of the things you may have learned in physics. Now we're ready to move on and look at some examples of calculus using vectors and parametric equations. Thank you for watching. Have a wonderful day.